Welcome to Maker Model College online tutorial. We hope at the end of this lesson, you will have acquired the expected learning outcome. Sit down and listen attentively as we introduce your subject teacher.
Welcome you back to another class of mathematics. I am Adobaz Abdullahi. Previously, we've discussed the 6 laws of indices. The first one is multiplication law, where we said whenever you are given a raised to the power of x multiplied by a raised to the power of y, the result is going to be a raised to the power of x plus y. The second one is division law, where we said a raised to the power of x divided by a raised to the power of y, the result is going to be a raised to the power of x minus y. The third one was zero law, where we said any non-zero value raised to the power of 0, the result is going to be 1. The reciprocal law, we said any non-zero value raised to the power of a negative non-zero value, the result is going to be inverse of that value. That is, if you are given x raised to the power of minus a, the result is going to be 1 all over x raised to the power of a. The other laws that we looked at the other time also include the power law, where we said if you have a raised to the power of x open and close brackets or raised to the power of y, the result is going to be a raised to the power of xy. And the last one we discussed was the root law. And the root law was telling us that if you are given the root of a, the result is going to be a raised to the power of half. Or if you are given cube root of a, the result is going to be a raised to the power of 1 over 3. This minute, we are going to use those laws to solve more examples in this our lesson. The first example that we are going to look at this minute, the first one is asking us to evaluate, open brackets, 2a raised to the power of 3, close brackets, or raised to the power of 2, times, open brackets, 4a raised to the power of 6, close brackets, or raised to the power of minus 2. The second one is asking us to evaluate 16 raised to the power of 3 over 4. Multiplied by 4 raised to the power of 1 over 2. Everything divided by 8 raised to the power of 5 all over 3. The solution of the first question goes thus. The second question is asking us to evaluate, open brackets, 2a raised to the power of 3, close bracket, 2, which is to the power of 2, times, open bracket, 4a raised to the power of 6, close bracket, or raised to the power of minus 2. You agree with me that you can express this open bracket 2a raised to the power of 3, close bracket, or raised to the power of 2, using the format of expressing everything within the bracket here, which is 2a raised to the power of 3 in two places by having 2a raised to the power of 3 times 2a raised to the power of 3. And in our previous lesson, I told you that if you are given a mixture of numbers and alphabets, you are going to separate the two. And if you are going to separate these two, the first thing that should come to your mind is the connectivity between these two and this A. And the connectivity is multiplication. So we are going to express these 2 raised to the power of 3 as 2 times a raised to the power of 3. You are going to do that same thing to this 2a raised to the power of 3. So the expression of this 2 raised to the power of 2a raised to the power of 3 or raised to the power of 2 will now be 2 times a raised to the power of 3 times 2 times a raised to the power of 3. And we are going to rearrange this for simplicity. We are going to rearrange this expression for simplicity. That is, you are going to group this number, which is 2 and 2, at one side. You also group this a raised to the power of 3 and a raised to the power of 3 at the other side. And if you must do that, you are going to have 2 times 2 times a raised to the power of 3 times a raised to the power of 3. And this 2 times 2, they are raised to the power of 1. And if you must apply multiplication law here, this expression of 2 times 2 will now be 2 raised to the power of 1 plus 1, because the connectivity here is multiplication. Likewise to this a raised to the power of 3 times a raised to the power of 3. The a here and the a here, they are the same. So we are going to pick one out of these 2 a's, and the connectivity is multiplication. We are going to add this 3 and this 3 here as the power of the a. So the expression will now be 2 raised to the power of 1 plus 1 multiplied by a raised to the power of 3 plus 3. And the 2 raised to the power of 1 plus 1 is going to be 2 raised to the power of 2 times this a raised to the power of 3 plus 3 is going to be a raised to the power of 6. And this 2 raised to the power of 2 is still the same thing as 2 times 2 as we had in the previous expression, which is going to give us 4. And this a raised to the power of 6 will be written along with 8. Therefore, this expression 2 raised to the power of 2a raised to the power of 3 open and close bracket all raised to the power of 2 is still the same thing as this 4a raised to the power of 6. So the other expression within this expression of the first question, which is 4a raised to the power of 6 open bracket close bracket all raised to the power of minus 2, can also be expressed in this format as we did to this 2a raised to the power of 3 open and close bracket all raised to the power of 2. And the expression will be given as will be given as 1 all over 4 a raised to the power of 6 open and close bracket all raised to the power of 2 if you apply reciprocal law here. And this minus is the one that brought about this 1 all over 4 a raised to the power of 6 all raised to the power of 2. And we are going to express this one in this 4 a raised to the power of 6 in 2 places because the power here is 2. So this expression of 1 all over open bracket 4 a raised to the power of 6 all raised to the power of 2 will now be 1 all over 4 a raised to the power of 6 times 4a raised to the power of 6. I told you earlier that you must separate the number from the alphabet. So we are going to separate this 4 from this a raised to the power of 6. And the thing that should come to your mind is the connectivity between the 4 and this a raised to the power of 6, which is multiplication. And if we are going to separate the two, we are going to have 1 all over 4 times a raised to the power of 6 times the same expression will be done to this 4 a raised to the power of 6. That is 4 times a raised to the power of 6. We are going to regroup. That is, you group the 4 at one side and the a raised to the power of 6 at the other side. And if we must do that, we are going to have 1 all over 4 times 4 multiplied by a raised to the power of 6 times a raised to the power of 6. And this 4 times 4, this 4 is having the same base as this 4. And mind you, the power is not indicated, but they are raised to the power of 1. So we are going to pick 1 and add the power because of the connectivity here. So we are going to have 1 all over 4 raised to the power of 1 plus 1 times this a and this a here, which is to the power of 6. We'll pick 1 out of the 2. The connectivity is multiplication. We are going to add the power. So we are going to have a raised to the power of 6 plus 6. And that same expression will be equals 1 all over 4 raised to the power of 2 times, if you add this 6 to this 6, you are going to have 12. So you'll be having a raised to the power of 12. And if you do the expression of this one, as we had here already, 4 is 4 times 4. And 4 times 4, you agree with me, is going to give us 16. You are going to have the results from here, where we have 1 all over 4 raised to the power of 2 times a raised to the power of 12 to be 1 all over 16 a raised to the power of 12. And we are going to substitute the expression we did now to the previous question that we were given. The expression is given to the open brackets 2a raised to the power of 3 close bracket all raised to the power of 2 times open brackets 4a raised to the power of 6 close brackets to the power of minus 2 equals the expression of this open bracket 2a raised to the power of 3 all raised to the power of 2 is 4a raised to the power of 6. And the expression of this open brackets 4a raised to the power of 6 close brackets to the power of minus 2 is given to be 1 all over 16a raised to the power of 12. And if you multiply this 4a raised to the power of 6 by this one, the result will still remain the same. That is, we are going to have 4a raised to the power of 6 all over this 16a raised to the power of 12. And 4 will now divide. If you divide this 4 by itself, the value is going to be 1. If you divide this 16 by 4, the result is going to be 4. Fine. I told you earlier that if you are given this, you must separate the number from the alphabet. So we are going to separate that. We are going to have 4 all over 16 times this a raised to the power of 6 all over this a raised to the power of 12. And 4 into 4 will give us 1. 4 into this 6 will give us 4. And the expression of this 4 over 16 is still the same thing as 1 all over 4. And if you apply division law in this case, this a raised to the power of 6 divided by a raised to the power of 12, you are going to pick one out of these two a's. Then you are going to subtract the second part from the first one, which is 12 from 6, not 6 from 12. Because this 6 comes first before this 12. So we are going to have a raised to the power of 6 minus 12. And the result from there is going to be 1 all over 4 times a raised to the power of, if you minus 12 from 6, you are going to have negative 6. And this 1 all over 4 still remains 1 over 4. 1 over 4 multiplied by, if you apply reciprocal law here, you are going to have 1 all over a raised to the power of 6. Because of this negative here, this negative is the one that brought about this 1 all over a raised to the power of this initial 6 here. And 1 times 1 will give us 1. This 4 times a raised to the power of 6 is going to be 4a raised to the power of 6. And this question given to us as 2a raised to the power of 3 open and close bracket all raised to the power of 2 times open bracket 4a raised to the power of 6 close bracket all raised to the power of minus 2 is a long expression for 1 all over 4a raised to the power of 6. This 1 all over 4a raised to the power of 6 is the short form of the initial question given to us. The solution of the second question goes thus. The solution of that second question is this. The second question is given to us to be 16 raised to the power of 3 all over 4. 16 raised to the power of 3 over 4 times 4 raised to the power of 1 over 2. Everything over 8 raised to the power of 5 over 3. You agree with me that the smallest denomination here is this 4. But we cannot express this 8 to this denomination, where you'll be having another denomination that will be smaller compared to this 4. That is, if you now multiply 4 by 2, 2 is now smaller compared to this 4. So we are going to express this 8 and this 16 as well as this 4 to the denomination of 2. If you now express this 16 to the value of this 2, you are going to have 2 raised to the power of 4. That means that if you multiply these 2 into 4 places, you are going to have 16. And if you must express this one to the value of this 2, you are going to have 8 equals 2 raised to the power of 3. That is to show that if you multiply this 2 into 3 places, you are going to have 8. This 4, if you express it to the value of 2, you are going to have 2 raised to the power of 2. That is 2 times 2. So instead of this 6 to be reflecting in this our initial expression, we can now remove the 16 from there and replace from this expression and put this 2 raised to the power of 4 there. You remove this 4 from this expression and put this 2 raised to the power of 2 there. You remove this 8 from this expression and put 2 raised to the power of 3. Therefore, this expression where we have 16 raised to the power of 3 over 4 times 4 raised to the power of 1 over 2, everything over 8 raised to the power of 5 over 3 will now be 2 raised to the power of 4. The initial power will now be in brackets because this 2 raised to the power of 4, this 4 will now be multiplying this 3 over 4. That is why we introduce this bracket here. Multiply by this 2 raised to the power of 2 in place of this 4. The initial 1 over 2 will be within the brackets. All over, in place of this 8, you now put this 2 raised to the power of 3. 2 raised to the power of 3 and the initial power there, which is 5 over 3, will now be within the brackets. You agree with me that if you multiply this by this 4 by 3, you are going to have 12. And if you divide it by 4, you are going to have 3 as well. Better still, you will tell them that this 4 will strike this 4. This 2 will strike this 2. This 3 will strike this 3. So this expression here will now be, if this 4 strikes this, the remainder here is going to be 3. So you are going to have 2 raised to the power of 3. Multiply by, if this 2 strike this 2, the remainder there is 1. Without indicating it, this 2 is raised to the power of 1. All over this 3, if it strikes this 3, the remainder is going to be 5. And you'll be having 2 raised to the power of 5 at the denominator. We are going to apply multiplication law here, and you are going to pick one out of these two bases. And the result from there is going to be 2 raised to power of 3, the connectivity is multiplication, plus the 1 as the power of these 2, all over 2 raised to power of 5. And 2 raised to power of 3 plus 1 is still the same thing as 2 raised to power of 4 all over 2 raised to power of 5. If you apply division law here, you pick one out of these 2, you are going to have 2 raised to power of 4 divided by 2 raised to power of 5. And the connectivity here is division, therefore you are going to have 2 raised to power of 4 minus 5. And the result from there is going to be 2 raised to power of minus 1. And if you apply the reciprocal law here, you are going to have 1 all over 2 as the final result from here. That is the solution of the second question.